So my question for today comes from the chapter of electrostatic 2, which talks about the capacitors and the resistors. So we have a capacitor and a resistor, and there's a difference between the two. So from the question, we have capacitance and a capacitor. So let us know the difference between the two. So we have a capacitor and a capacitance. The difference between the two is that a capacitor, this is a device, this capacitor is a device which is used to store charges, and the capacitance is the quantity of charge. The capacitance, which is denoted by C, is the quantity of charge per unit volt. So the definition of the capacitor, just from the formula of calculating the capacitance is the quantity of charge per unit volt, while the capacitor, this is the device which is used to store charges. Now, coming back to the question, we have three capacitors of capacitance: 1.5 microfarads, 2 microfarads, and 3 microfarads are connected in series. So the key word here is in series. Now, there's usually a confusion between capacitors connection and the capacitor connection. Now, sometimes you might be confused which formula are you going to apply while solving some questions involving the calculation. Now, the formula is very easy. So just write the capacitor. We have the capacitance. Capacitance can either be connected in series or in parallel. So when you connect capacitance in series, just go with par and par. So this is the linear. So the effective capacitance CT is equal to C1 plus C2 plus that's out to the last one. So if this one is the linear, this is the linear capacitance now. Now it means that the other one will now be the fraction one. So the effective capacitance in series will be 1 over CT is equal to 1 over C1 plus 1 over C2 plus, out of the last one, 1 over Cn. So this one should be Cn, the last one, 1 over Cn. Now for resistors, now let us go to resistors. Resistors, we have connection in series and the connection of resistors in parallel. So the resistors also can be connected in series and also can be connected in parallel. Now resistors ES series is also ES. Now this is the linear one. So when you say RT is equal to R1 plus R2 plus Rn. The same thing now parallel. Now it's the vice versa. 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 up to 1 over the last one, Rn. Now, that is the simplest way to master whether you are going to use the reciprocal one or you are going to use the linear one, the fractional one or the linear one. Now, the resistors are connected in series now. The capacitors now are connected in series. Now, we are going to use which formula? Capacitors in series is 1 over Ct. Now, we say 1 over Ct is equal to how many capacitors do we have? In this case, there are 3 capacitors. 1, 2, 3. So it's the same as 1.5. 1 over 1.5 plus 1 over 2 plus 1 over 3. So this gives you, when you solve that mathematics, it will give you 9 over 6. You're going to find it to be 9 over 6. So the effective capacitance now, because this 9 over 6 represents 1 over Ct. So it means that Ct, the effective capacitance, is the same as 6 over 9, which is equal to 0.6667 microfarads. So this one is 0.6667 microfarads. So now, question B, the total charge now. The total charge from the formula of capacitance is the quantity of charge per unit volts. Now, Since we have the capacitance is defined as the quantity of charge per unit volt, we say that C is equal to the quantity of charge per unit volt. Now it means that the total capacitance, which is the effective capacitance, is the same as the total charge over the total voltage. Now to get the total charge, we multiply everything by Vt, the total voltage Vt. So quantity of charge, total quantity of charge in this case, is the total capacitance, which is the effective capacitance, multiplied by the total voltage, the PD source. This is the same as the voltage, which is 12.0, multiplied by the combined capacitance, the effective capacitance, which is 0.6667. So this will give you 12 times 0.6667 will give you 7.9968 microcoulombs. So this is the total charge. So this is the same as 7.9968 microcoulombs. So that is the total charge. The charge on each capacitor, that is what you will see. Charge on each capacitor. Now, since the capacitors are connected in series, each capacitor will have equal number of charges. So you say since capacitors are in series, charge across 1.5 is the same as charge across 2.0, which is the same as the charge across 3.0. So in this case, we say that charge are equal. Charge flowing through each capacitor is equal, which is the same as 7.9968 microcoulombs. So that is the charge on each capacitor. 7.9968 microcoulombs. And finally, the voltage across the capacitor of 2 microfarads. So again, because we already have the charge across 7.9968, the charge which is across 2 microfarad is 7.9968. So it simply means that the capacitance, which is the quantity of charge per unit volt. So to get the voltage, V is equal to quantity of charge over the capacitance, which is equal to 7.9968 microfarads. Then you divide by 2 microfarads. This one should be microcoulombs. 2 microfarads. So I have, this was a correction. This was supposed to be microcoulombs, the charge. And this is microfarad. So this one will get your answer to be 3.9984 volts. So this is the potential difference, the voltage